Welcome back. So in this segment, we're going to talk about variability. Anytime you measure something, you have two issues you have to deal with: reliability and validity. Reliability is another word for consistency. If I have a reliable car, then every time I put the keys in the car and turn it on, the car starts. Many of us have had unreliable cars, so reliability we know, right? If I turn on the key to the car, is the car going to start every time? That's reliability. Validity is different. Validity is about accuracy. So I'm using the examples here of you could think of them as darts on a dartboard, or I used to be a competitive archer, so arrows on an archery target. When something is valid, you're using the right tool for the job, and your results are accurate. So, for example, if I had a 12-inch long measuring stick, and I used that to measure how far it is from where I am here in Los Angeles all the way up to San Francisco, I would not have the right tool for the job. My measure would not be accurate, and it would be highly variable. Okay, so in the previous lecture, we talked about measures of central tendency. Now we're going to focus on the issue of variability. How much noise is there in the data? If something has low variability, then it's very consistent. And on the left-hand side there, you can see an archery target with 3 arrows, and they're all in the bullseye, and there's little variability. Where one point is, they all are. In the target on the right, the arrows are in very different places. So there's high variability. Just because one arrow went to one spot on the target doesn't mean the next arrow is going to go there. It could go anywhere. You can also see variability in curves. And I think the best thing to do is just jump ahead to the next graph here that shows you a low variability curve and a high variability curve. So imagine a test that your professor gives where everybody in the class gets a B. Maybe the scores range from B- to B+. There's very little variability in that distribution of grades, right? Everybody's in around a B. That's the narrow blue curve on the chart you're seeing, on the graph you're seeing now. There's also a green long curve that's kind of flat. That would be a high variability curve. To use the analogy of scores on an exam, if the frequency distribution of grades on an exam looked like that green curve, there would have been a lot of every different kind of grade. Okay? Now, there's multiple ways that you can think about variability. One of them is in terms of range, and that's what we're going to look at first. Range is super simple. It's how great is the distance between the lowest score and the biggest score. So notice that in the low variability curve, the distance between the lowest point and the highest point is small. But in the high variability curve, the distance between the lowest number and the highest number is big. That's range, right? When there's low variability, the range is small. Here are some pictures of men and women who appeared in the Guinness Book of World Records. Each picture shows, on the left it's women, the tallest woman who ever lived and the shortest woman who is currently alive. And on the right-hand side, you see the tallest man who's ever lived, 8 feet 11 inches, almost 9 feet, that's tall. And the shortest man who ever lived, who is or was 21 and a half inches tall. The difference between those two men or those two women, that's the range. Okay? You can see in this case, the range would be very big, right? We're talking about a range that's over 6 feet. The difference between the shortest person and the tallest person is over 6 feet. It's tremendous range. When you look at heights of men and women, so here are two frequency distributions. One is for the heights of men, the other is for the heights of women. What you can see is that the curves for women is a little narrower. The distance, the range is smaller. Men have a larger range of heights, which means there's more variability in men's heights than there are in women's heights. The same thing actually happens with men and women with IQs. Men have a larger range of IQs. So there are men who are smarter than women, but there are an equal number, according to IQ measures, which we'll get to later because that's a whole other can of worms. There are, according to IQ measures, men who are smarter than women, but there's also an equal number of men who are dumber, have lower IQ scores than women. So that's range. What's the difference between the top score and the bottom score? Okay, so here's let's see if you've understood this. Imagine you're working for the San Diego Zoo, what a cool place to work, and your boss asks you to compute the range of bear sightings. And you have this chart that I'm going to expand here. The range of bear sightings. Well, let's see. What month has the largest number of bear sightings? And what month has the smallest number of bear sightings? The difference between those 2 months is the range. Mathematically, most people use a more sophisticated measure of variability called standard deviation. The bigger the standard deviation, the more variability there is. That's all you need to know for this class. So I've got 2 lines there with some X's. The X's are supposed to be data points. The top line has 3 data points that are fairly close together. That's low variability, and it would be a small standard deviation. The bottom line has 3 points spread apart. That's higher variability, would be a higher standard deviation. And that is it for variability. Come back and we'll have a short segment on inferences.